Hello. During this video, we will go over the problems in the Algebra 2 review sheet for sections 7.1 to 7.4. This is where we're solving systems of equations. All right, the first way we learned how to do it was by graphing. Remember, systems of equations, system just means more than one. And there's three possibilities. We could have two lines that cross at one point, intersect at one point, that's one solution. We could have two lines that are parallel. There's no solutions there, right? Or we could have two equations that are exactly the same line and we could have infinite solutions. Let's see what we have here. All right. In order to graph these, I'm going to put them into y equals mx plus b form. So I will subtract x over for this first one. 2y equals negative x plus 7 divided by 2, y equals negative 1/2 x plus 7 over 2. All right, well, I'm going to graph this line. My y-intercept is 7/2, which is about 3.5. And my slope is negative 1/2. That means down 1 over 2. All right? Now, it's a little hard to draw with a straight edge here. Let's see if I can do it. We'll see how it works. All right. The second, 3x minus 2y equals 5. I'll subtract 3x over. Negative 2y equals negative 3x plus 5. I'll divide by negative 2. So y equals 3 over 2x minus 5 over 2. So now our y-intercept is negative 2.5, and this is a positive 3/2 slope. So that's up 3, 1, 2, 3 over 2. All right. We're going to see. All right. If I kind of look for what I think is the intersection, it might be 3, 2. But the only way I'll know is if I check it. So if I check it in the first equation, I get 3 plus 2 times 2 is 4 equals 7. That works. And then in the second equation, 3 times 3 is 9, minus 2 times 2 is 4 equals 5. That works. So I found my first solution. It turns out to be an intersection of the line. Let's do the same thing here. I want to put it into the y equals mx plus b format. So here I'll add x to both sides. Y equals x minus 7. So 1, 2, 3, 4, 5, 6, 7, and my slope is 1, up 1 over 1, right? So basically it does that. All right, the second one, x plus 4y equals negative 8. 4y, I'm going to subtract the x over, and divide by 4. Y equals negative 1 over 4x minus 2. So minus 2, negative 2 is my y-intercept, and my slope is down 1 over 4, down 1 over 4. Ooh, look at that. It happens to be our intersection point, which is 2, 3, 4, negative 3. And if I check that, 4, negative 3. Negative 4 minus 3 equals negative 7. That one works. I'm just checking them on these equations. 4 minus 12 equals negative 8. It works. So those are my two solutions by graphing. And remember, we said graphing is not a practical way to do it, just for this reason. Okay, moving on. Determine whether the given ordered pair is a solution to this linear system. Well, you have to just plug it in. You have to substitute. 2 times the x of 5 minus 3 times 2. Does that equal 4? Let's see. 10 minus 6 equals 4. Well, that one works, but let's try the second one. 2 times 5 plus 8 times 2 equals 11. Does that work? This is 10 plus 16 equals 11. Nope, that doesn't work. So not a solution. Not a solution. Let's check the second one. Okay, x negative 3 plus 1 equals negative 2. That works. Let's try this. Negative 3, plus 5 times 1. 2, that works. So this is yes. Mathematically, what does the solution of a system of linear equations represent? It's a point, a coordinate point, that is a solution to both equations. All right? And number 6 is, what are the 3 possibilities in the solutions for each? Well, we've actually already answered this. The first possibility is that the lines will intersect in one point, so there's one solution. The second possibility is that the lines are parallel and they'll never intersect, so there's 0 solutions. And the third is if the equations are the same line and they intersect at an infinite number of places along the line, so an infinite number of solutions. Okay? Now this, we are going to solve these with substitution. So when we're doing substitution, we solve one of the equations, right, for one of the variables. It's in your best interest to look for something that has a coefficient of 1 or negative 1. I shouldn't write the word out, I'll say 1 or negative 1. Then we'll substitute that in the second equation. All right, so in this first set, actually y is already solved for in that first equation. So wherever y is here, I can substitute 2x plus 5. So I'll rewrite the second equation. 3x plus the y of 2x plus 5 equals 10. Let's solve that. 3 and 2 is 5x plus 5. Those pluses aren't looking very good. Subtract 5. 5x equals 5, x equals 1. Once I have that 1, I go right back into the original equation, and I get the other variable. So my answer should be 1, 7. I'm going to eyeball that again. 3 plus 7. Yeah, it looks like it works. All right, now in number 8 here, we need to take one of these equations and solve for one of the variables. I'll take this one. If I have x minus y equals 3, why don't I add y to both sides, and I'll get x equals y plus 3. So now in this equation, wherever x is, I can substitute in y plus 3. Y plus 3 plus 2y equals negative 6. 3y plus 3 equals negative 6. Subtract 3y equals negative 9. Y will equal negative 3. Now again, I take this, I plug it right back into that original equation. X equals negative 3 plus 3, which is 0. So this should be my solution, but I'm going to look at both of these to make sure it works. And it does. Okay. Now, over here, remember, look for something that has a coefficient of 1 or negative 1. That makes your life easier. So I'm going to take this equation and solve for the y. Okay, and then y then equals negative 3x minus 7. Wherever y is in the second equation, I can substitute in negative 3x minus 7. So negative 2x plus 4 times this y equals 0. So let's distribute. Negative 2x minus 12x minus 28 equals 0. Negative 14x minus 28 equals 0. Add the 28 to both sides. X equals negative 2. Take that right back to this original equation. Negative 3 times negative 2 minus 7. 6 minus 7 is negative 1. Y will be negative 1. My answer should be negative 2, negative 1. Let's check it out. Negative 6 minus 1 is negative 7. Negative 4. I'm sorry, 4 minus 4 is 0. That works. Right? So that was using substitution. Let's try 2 of these word problems. The sum of the ages of Pat and her brother is 35. Her brother is 1 year less than twice as old as Pat. How old are Pat and her brother? All right, I'm going to say X is Pat's age, and Y is her brother's age, okay? So the sum of those ages is 35. Well, that gives us one equation, x plus y equals 35. Now our second equation comes from the next sentence. Her brother, y, is 1 year less than twice as old as Pat. All right, so Pat is x, twice as old as Pat is 2x. 1 year less than that, if I take one off, that will be y, her brother. All right, now I have two equations. Notice this one has y already all by itself, so I can substitute that in right there. So x plus the y of 2x minus 1 equals 35. 3x minus 1, add 1 to both sides. X equals 12. Now that's Pat's age. I can take that right back here to get her brother's age. 2 times 12 minus 1. 24 minus 1. 23. So Pat is 12 years old, and her brother is 23 years old. Okay? Number 11 says, a library is having a book sale. Hardcover books cost $4. Paperback books cost $2. Well, somebody bought 8 books and spent $26. Well, how many hardcover books did she purchase? Well, we need to define some variables. We need to find the number of books. Let's call X the number of hardcover books, all right? Y the number of paperback. Well, we know they bought a total of 8 books. Well, the number of hardcover plus the number of paperback has to equal 8. But how about the value? They spent $26. Well, each hardcover book is 4, so $4 times each hardcover book she bought, plus $2 times each paperback book she cost should be $26. I could solve this by substitution or elimination. I'll use elimination since we haven't done that in the story problem yet. I am actually going to take this first equation and multiply through by -2. All right? By -2 because I want a -2 in front of y. So this becomes -2x minus 2y equals -16. If I rewrite the second equation, it looks like this. And I'm going to add them together. -2x plus 4x is 2x. -2y plus 2y, y is eliminated. -16 plus 26 is 10. X equals 5. Well, that's how many hardcover books she bought. If you needed to know how many paperback books she bought, you go back to the x plus y equals 8 and find out she bought 3 paperback books. All right? So your answer will be 5 hardcover books. All right. On the last page of this, we're actually going to use elimination. All right? See if we can get through this. We want to get one of the variables to have the same number, different sign, so that when we add these together, they are eliminated. All right, I'm actually going to multiply this through by 2. So that, here's the first equation. When I multiply through, I get -2x plus 2y equals 2. And look, my y's are eliminated. 3x minus 2x is x. 3 plus 2 is 5. X equals 5. Go back to either equation to get y. I'm going to add 5. Y will equal 6. So that's the answer there. Now, in the second one, it's a little more difficult. I'm going to stop here and do the last two in a separate video.